Welcome to the deep dive. You gave us the sources, and now we're ready to really dig in.
Yep, let's do it.
So today we're plunging into, well, what looks like a pretty complex area, high-density video distribution. Specifically, this WolfPack Lite 16x16 1080p HDMI Matrix Switcher system.
Right, and this isn't just, a simple splitter. We're talking a serious piece of kit. Okay. An architectural solution, really, for big installations. The core problem you've asked us to tackle, looking at these sources, is how do you manage maybe 16 different video inputs? Things like DirecTV, Apple TVs, whatever you've got.
A whole mix.
A whole mix, yeah. And route any one of those to any one of maybe 16 different TVs or displays. And here's the kicker.
The distance.
Exactly. Over really long distances, hundreds of feet sometimes, without the picture falling apart or getting messy.
Yeah, that's the mission, isn't it? Because when you think about sports bars, big offices, command centers, even some large homes.
Yep.
The gear rack is often nowhere near the screens. An HDMI cable gives up after, 50 feet max?
Yeah. If you're lucky. Yeah. Pretty much useless for these scenarios. So you absolutely need something specialized.
And that's where this matrix switch comes in.
Right. It gives you that total flexibility. Input A to output Z, input B to output Q, any combo.
But doing that at 1080p over serious distance, traditionally that meant big, expensive fiber optic cables, didn't it?
Oh, yeah. Fiber, or maybe a whole chain of signal boosters, balloons, repeaters. Lots of complexity, lots of places for things to fail.
Yeah.
A real headache.
Okay, let's unpack this then, because the sources highlight something that sounds like a major breakthrough, maybe changing the whole cost picture.
What's that?
Extending full 1080p video up to 450 feet. That's huge. But not over fiber, over regular network cables. CAT6, CAT5e, CAT7, stuff that might already be in the walls. That feels like a revolution for installers.
It really is a big deal. And what's interesting is the tech they mentioned for doing this. It's called LHDT in the documentation, long HDMI distance technology.
LHDT.
Now, the wider industry uses terms like HDBaseT for sending AV over Sakai cable. And the company here, HDTV Supply, they're actually an approved adopter of HDBaseT.
Oh, okay.
So while LHDT is their specific term, it achieves that same kind of strategic goal, using standard affordable network wire instead of specialized pricey AV cables.
Right. So if it's using standard Sakai cables, does the quality really hold up over 450 feet? That seems like a long way for a video signal on copper. What's the magic LHDT is doing?
Well, the challenge is always signal loss, degradation, timing issues over that distance. You're pushing a lot of data.
Yeah.
But the claim they make is pretty bold. They say the picture quality, even after that 450-foot run, quote, looks like you were using a 3-foot HDMI cable.
Wow, okay.
Which suggests they've built in some really robust error correction, signal boosting, conditioning, basically making sure things like dropouts, sparkles, color problems just don't happen.
Yeah.
Tackling those long-run headaches.
That's impressive. Now, beyond just the signal distance, there's another practical problem in big setups. Power.
Oh, yeah. Always.
If you've got 16 TVs spread out, that normally means 16 little HDMI receiver boxes near the TVs, each needing its own power adapter, its own wall outlet. That's a mess. 16 power bricks to hide, 16 outlets to find.
It's a nightmare. 16 more things that can fail or get unplugged behind a TV. It's all for the simple stuff like power that causes service calls.
So how does the system handle that?
This is where it gets really elegant. It uses PoE, power over Ethernet.
Ah, okay. Makes sense.
The main switch unit itself actually sends the necessary power down the same CA cable that's carrying the video signal.
So the little receiver box at the TV doesn't need its own separate power adapter.
Exactly. No external AC adapter needed at the display end. The power comes right from the central switch. Clean.
Now, if you're planning a big install, the savings from PoE, it's more than just not buying 16 power bricks, isn't it?
Oh, absolutely. Think about the electrician costs.
Yeah.
You avoid running 16 new AC power lines or installing 16 new outlets near the displays.
Which might be difficult or expensive in some buildings.
For sure. So it cuts down installation time, complexity, costs. And it boosts reliability because your power is centralized at the switch. Fewer points of failure spread all over the place. Every installer hates finding a power brick that's just worked itself loose.
Yeah, definitely simplifies things. Okay, so we've got the distance and the power sorted. What about the actual content? We're in an era of tight content protection.
Crucial point. If your hardware doesn't play by the rules, the content sources just stop working. Black screen.
Right. So compliance is key. The sources say the system supports HDMI 2.0 and, importantly, HDCP 2.3.
Yes, and that HDCP 2.3 is basically non-negotiable now.
Why is that? If you're connecting, say, a new Apple TV 4K or the latest cable box.
HDCP, high bandwidth digital content protection. 2.3 is the latest version. It's like a digital handshake. Your source device, your Apple TV, Roku, DirecTV box, checks the gear it's connected to, the switch, the display, to make sure they're secure and compliant.
To prevent illegal copying and stuff.
Pretty much. If your switch only supports an older version, like HDCP 1.4 or even 2.2, the source sees that, thinks, nope, not secure enough, and it just cuts the signal. That's when you get these annoying content protection error messages.
So HDCP 2.3 isn't just a nice-to-have feature. It's essential for modern sources to even work.
It's absolutely fundamental. Without it, a lot of the premium content sources you'd want to connect simply won't display.
Okay, compliance covered. What about performance, user experience? If you're managing multiple feeds, say in a control room, you need fast switching. Slow changes are useless.
Good question. Does all this security and distance tech slow things down? The sources actually give numbers for this. Fast 80 meters switching and 80 meters latency.
80 milliseconds. How fast is that in like real world terms?
It's really quick for this kind of device. Humans usually only notice lag or delay when it gets over maybe 150, 200 milliseconds.
Yeah.
So 80 meters means if you switch source 3 to display 12, it feels almost instantaneous.
So you avoid that long black screen pause you sometimes see.
Exactly. Critical for dynamic situations, live events, security monitoring. You need that immediate response.
Need security. Okay. Let's talk scalability. Not everyone needs a full 16 inputs and 16 outputs from day one.
Right. And that's another interesting aspect, the modular design. It's not one giant fixed 16 by 16 box.
How does it work then?
The main chassis uses 4 port cards. You basically slot in cards for inputs and outputs as you need them, so you can build exactly the size you require. Maybe start with a 4x4 or an 8x12.
Or even something unusual like 12 inputs but 16 outputs.
Yep. The documentation lists all sorts of configurations, 4x12, 12x16, 16x4. It's very flexible. You build your own matrix, essentially.
That sounds like it offers huge value, especially for budgets. You don't have to overbuy up front.
Absolutely. You can phase it, buy the chassis and enough cards for your 8x8 needs now. Then next year, if you expand to 16 screens, you just buy more output cards and slot them in. No need to replace the whole core unit. It scales with your project.
Okay, here's where it gets really interesting, I think. Moving beyond just basic switching into more advanced professional features, the sources mention free video wall processing is included.
Yeah, that's a big one. That takes it beyond just sending one source to one screen.
How does that work?
Video wall processing lets you take a single source image and stretch it or tile it across multiple physical screens, acting together as one giant seamless display, like a 2x2 or 3x3 grid of TVs showing one big picture.
And that's built in. Usually that requires separate expensive hardware, right? A dedicated video wall controller.
Typically, yes. So including it free is a significant value add, especially for places like command centers, retail displays, or big presentation venues. Saves thousands on extra gear.
And controlling a system this potentially complex, you need options?
Definitely. Can't rely on just one method. The sources list 3 main ways. Dedicated apps, presumably for mobile devices, quick changes, a full WEB GUI, like a web page interface for detailed setup and control.
Okay.
And physical buttons right there on the front panel of the switch itself. That last one is crucial for backup, If the network goes down, you still have direct control.
Let's go back to those modular cards for a second. You said they're not just ports, they have processing features.
That's right. There's some smart stuff happening right on the cards themselves, like resolution scaling.
Why is that important?
Imagine you have mixed sources, maybe an old 720p security camera feed and several newer 1080p media players. But all your displays are 1080p.
Right.
The scaling on the card ensures that the lower res 720p source is properly scaled up to fit the 1080p screen without looking weird or distorted, while the native 1080p sources pass through perfectly. It handles those mixed resolution environments smoothly.
The documentation also mentions separate audio on all cards and an optional quad view card.
Yep. Separate audio means you can de-embed the audio from the HDMI signal and route it independently, maybe to a separate sound system, which is useful if the speakers aren't near the screens.
And quad view.
That's pretty cool. A quad view card lets you take 4 different input sources and display them simultaneously on a single screen, usually in 4 quadrants. Turns one monitor into a multi-source dashboard. Really useful for monitoring multiple things at once.
You mentioned the pricing earlier. The huge difference really shows the scaling potential.
Yeah, that contrast kind of sums it up. The sources mention a base cost for the build-your-own chassis starting around $600. That's your entry point.
Okay.
But then a fully loaded pre-configured system, like the example of a 12x16 setup with all the cards and receivers, is listed at $3,800.
Oh, quite a range.
It really illustrates how it can fit a smaller initial need, but also scale up to handle really large, complex installations without needing a completely different product line.
So let's bring this together. What does this all mean for you, the listener, maybe managing a large facility or planning a complex AV install?
Well, I think it means
It seems like true enterprise-grade video distribution handling modern protected content, going long distances, is achievable now using standard network cables you might already have.
right. You get that modularity to grow, the simplicity of PoE for power, and these advanced features like video wall processing baked right in. It bridges the gap, making high-end capabilities more accessible.
And connecting this specific product back to the provider, HDTV Supply, Inc. They've been around 24 years, the sources say, and they're an HD-based adopter.
Yeah, that background suggests they're established players in this AV over Ethernet space. They understand the standards and the challenges of reliability, distance, and compliance. They're operating right at that intersection.
Okay, so given everything we've discussed, especially the 450-foot flame over CAT cable and the PoE benefits, here's a final thought for you to maybe explore further. The sources say CAT5E, CAT6, and CAT7 cables are all compatible, but what are the real-world performance differences you might expect when pushing that 450-foot limit? Does existing CAT5E really perform the same as brand new CAT7? What trade-offs should an installer budget for?
That's a good practical question.
And also think about the PoE savings. We talked about avoiding electrician costs, but if eliminating those 16 power bricks saves, say, a couple of hours of installation and troubleshooting time per display location, what's the true bottom line cost reduction across a full 16x16 system when you factor in that labor? Something to chew on for your next big project budget.